the last video, we learned about how units are basically representing different values that further quantify the number in measurement. And different units are used to measure different physical quantity. And physical quantity are basically physical properties of matter that can be quantified and measured using a measuring instruments. In this video, we are going to look at the different unit and what is the system of unit that our scientists use today. Today, we use something called the International System of Unit, or basically the SI unit. And here are some characteristics about the SI. And the SI unit are basically the modern form of the metric system. One beautiful thing about the SI unit system is that it is based on fundamental unit called SI base unit. And we only have 7 or 8 SI base unit. However, one of the most amazing thing about the SI unit system is that it is based on prefixes that represent a specific 10 to the power of something. So different prefixes represent different 10 to the power of x. And that this can be defined by the decimal place in a number. So this is the most amazing thing about the SI system. Now let's look at the SI base unit. Like I mentioned before, there are 7 or 8. If we include liter for volume, there would be 8 units of the SI system. And the beautiful thing about the fundamental units is that they are like the 26th letter in the English alphabet. And we combine the letter to make different words that have different meaning. For example, we know that LOVE represent love. Or we have HATE represent hate. They have completely different meaning. In the SI system, there are only 8 letters. And the letters are meter, kilogram, Kelvin, liter, mole, second, coulomb, and candela. And the properties of each of the SI base unit are described in this beautiful table. The first 8 are the SI base unit. So if we look at this table, we have the physical quantity that each of the SI base unit will use to measure. Then we have the symbols that represent the physical quantity in an equation. Then over here we have the abbreviation of the SI base unit. Because when we record our measurement, we're not going to write the whole entire word meter, kilogram. That would take too much time. Then of course we have the dimension of the unit. Since the SI base unit are the fundamental unit of the SI system, you would expect the dimension to be the same as the abbreviation throughout. And of course they are the same throughout. Until we get to down here, we have something called Debride Si unit system. We talk about that later. But now let's go back to talk about this. We have kilogram is used to measure mass, which is represented by the letter M. Then we have liter used to measure volume, which is represented by the V. Then we have the unit mole used to measure the amount of substance, represented by the italic n, lowercase. Then we have second, used to measure time, represented by the lowercase t. Then we have Kelvin, used to measure temperature, represented by the capitalized T. Then we have Coulomb, used to measure electric charge, represented by the uppercase letter Q. Then we have candela, used to measure luminous intensity, represented by a capitalized italicized I. And also, we have the abbreviation for each of the SI base unit. Now let's move down and talk about the Debride Si unit. If we look at the dimension, we know right away it's something different. That is, for the dimension of the Debride Si unit, we have multiple SI units combined together. Then we look at the term Debride. Debride means originating or originated from something. In this case, this something is the SI's base unit. So basically we can make new Debride Si unit by combining base unit, either multiplying and or dividing SI's base unit. For example, we look at density, okay? Density is, the unit for density is a Debride SI base unit because the unit for density is basically made up the SI base unit of mass divided by the SI base unit volume. An example of a unit for density is kilogram per liters. Notice how we have kg, that's the SI unit kilogram. Then we have L, that's the SI unit for liter. So in this case, different SI's base unit are divided by each other to make the Debride unit density. Let's look at another example. Let's look at area. The unit for area is also Debride. We know that area is equal to length times width. An example of a unit for area is meter squared. Now meter is the SI unit that used to measure distance, right there. So if we take meter times meter, we have meter squared. So in this case, you can have the same SI unit that is multiplying each other to generate a Debride SI unit. Now sometimes we have a very complicated Debride SI unit. For example, look at the unit of energy. It's joule. And joule is represented by the letter J. But the dimension of J, or joule, is basically kilogram times meter squared over second squared. So don't get tricked by just one single letter when it comes to the Debride unit. Look at the dimension of it. So by now, you should have a clear understanding of the function of the different SI base unit and how they are used to make new Debride units that are used to measure and quantify different physical quantities of matter. So thank you for watching. If you have any suggestion or comment about this video, please comment below so we can make better videos that make learning more personalized for you. So again, thank you for watching.